A nuclear device detonating in space is not a hypothetical scenario. It is a very real and serious counterspace weapon with far-reaching consequences. Now, as unlikely as it is that such a device is ever used in space, it's important to know what it is and why anybody would be willing to use it. But yeah, it's bad. It's really bad. And hopefully it's something that never happens. But since when has hope been a strategy? So what is a high-altitude nuclear detonation? Well, it's very much what it sounds like. As a counterspace weapon, it's a nuclear device being detonated in space. Now, in more practical terms, there are a couple ways such a device would be used. Firstly, and probably most likely, a nuclear-armed intercontinental ballistic missile would be launched and detonated at high altitude. Alternatively, a nuclear-armed missile can be fired from an aircraft and detonated at high altitude. Finally, and while possible but rather less likely to occur than the previous two, a nuclear device could be launched into space and then detonated at a future time. So in effect, a nuclear-armed suicide satellite. So why do it? Well, there are a handful of potential states which would consider using such a counterspace weapon, and every scenario in which they use it shares one common feature: desperation. Any use of a nuclear device at high altitude creates indiscriminate damage. So in other words, China, Russia, the US, and others are not going to use this counterspace weapon because they have more to lose than to gain. States like Iran and North Korea, on the other hand, are likely to use such a counterspace weapon if desperate enough. Now, there are a limited number of states that can utilize such a counterspace weapon, and while that limitation is encouraging, the fact that it even exists as an option is frightening. So on a somewhat more encouraging note, there are two international treaties that make using this type of counterspace weapon restrictive: the Outer Space Treaty and the Partial Nuclear Test Ban Treaty. So the Outer Space Treaty obliges states not to place or install any objects carrying nuclear weapons in orbit or celestial bodies. The Partial Nuclear Test Ban Treaty flat out bans all testing of nuclear weapons anywhere except underground, meaning that nuclear detonation tests in space are prohibited. But just because it may be illegal to do something does not make it unlikely to ever occur. So take whatever comfort you want from that. It doesn't give me any. Okay, now let's get into the features of a high-altitude nuclear detonation. And when analyzing counterspace weapons, it's important to consider 5 main characteristics: reversibility, attribution, awareness, attacker damage assessment, and collateral damage. So let's do it. The damage done is irreversible. It's supposed to be. Attribution is not difficult to ascertain because some states have early warning satellites that detect ballistic missile launches. Public awareness is guaranteed. It's likely the whole world will know and be aware of what happened within hours. As for the attacker's damage assessment, this is near real time. But most concerning is the collateral damage. Now, this counterspace weapon creates lasting damage in orbit. How? Well, through increased levels of X-ray radiation and the creation of additional charged particles in the Van Allen belts. These could persist for months or even years. And if that's not worrying enough, then listen carefully to this. It is likely that a 10-kiloton nuclear device set off at the right height would lead to the loss of 90% of all low Earth orbit satellites within a single month. Okay, homework done. Now let's get into the interesting stuff. Has this counterspace weapon ever been used? What are the dangers and consequences of such an attack? And what does the future hold for this counterspace weapon? Now to do that, follow the link in the description, sign up to a level, and I'll get straight into it. Thanks for watching.